To start today's lecture, we're going to talk about carbon emissions and how they've changed over time. Next, we'll think about what carbon emissions might look like in the future. A great website is listed below. This is a great place to go and get further information. We can divide human emissions by source. This figure shows how human emissions of coal, oil, gas, and cement have changed from 1960 to 2017. Most of the plots I will show today are in gigatons of carbon dioxide. Remember that 1 gigaton of carbon equals 3.664 gigatons of carbon dioxide. Looking at this plot, what is the greatest source of carbon dioxide emissions? Coal and oil. The leader varies over time, but today it's coal. This slide shows how emissions from land use change or deforestation have varied from 1960 to 2017. There really is no clear trend in the data. The tan band shows the uncertainty in our estimates, which are relatively large. This slide compares contributions from fossil fuels to land use change from 1960 to 2017. Based on this slide, total emissions by humans in 2017 were 41.2 plus or minus 2.8 gigatons of carbon dioxide, which is equivalent to 11.2 gigatons of carbon. Contributions from fossil fuel burning are much larger than land use or land clearance. If you take a look at the tan and gray bars around the trend line, these are giving you an indication of uncertainty in the estimates. Note that we can estimate fossil fuel contributions much more precisely, that is smaller errors, than from land clearance. We can take a longer view of sources and how sources have changed over time. This slide shows contributions from different sources from 1880 to 2017. Land use was the main contributor up until 1950, when fossil fuel usage began to rapidly increase. This slide shows that total global emissions have steadily increased over time. There are variations in the rate of change, but emissions are always increasing. What do you think causes the variations in the rate of change? The variations in the rate of change are largely related to economic and technological change. This slide illustrates this relationship. In black, we see global carbon dioxide emissions. Note small short-term decreases are usually related to global economic downturns. With global economies shutting down as a result of COVID-19, there is expected to be a decrease of carbon dioxide emissions anywhere from 2 to 46% in 2020. But keep in mind, these changes are generally short-lived. In pink, we see emission intensity. Emission intensity is the emission per unit of economic impact, and it generally decreases over time. A decreasing emission intensity shows increasing efficiency and has largely been driven by technological advances. With increased efficiency, you might expect to see a decrease in carbon dioxide emissions. But our improved efficiency is not sufficient to offset the increasing rate we are burning fossil fuels.